Horizontal control. Say horizontal control. What is it? Okay, so what are horizontal controls? Usually, a civil engineer, an architect, whoever it is, need to know about this or these things called horizontal and vertical controls. Why? Because it actually holds the whole construction project. Okay. In fact, that is why the word control is being used, because otherwise the control is just a pillar or a certain point, a nail that has been nailed, put on the ground, for with a certain set of numbers associated with that nail or that peg, okay, or whatever it is, that a mark. So it's called control because it controls what you are doing. Are you get what I'm saying? All right, so let's just look at some of the things. The design points of the scheme can be correctly fixed in plan position. If you have horizontal control, then whatever you have in terms of design, you can now go and fix it in planimetry. Okay. So in planimetry, it's as opposed to looking at it from the section. Okay, so we talk about longitudinal sections and cross sections, things like that. This one is in the plan position. If you don't understand that, let's not move on. You need to find out, because I assume you understand everything that's got to do with that statement. Okay. And so if you are asked a question that you want to find out if you can critically analyze, the word plan position, the phrase plan position should be, understood from a certain point of view, as opposed to looking at a project in terms of longitudinal section or cross section. This one is the plan. Okay, plan position. So the whole project is in 3 dimensions. I have a cat here who always worries me when I'm doing these things. Okay, so the whole project is not on paper, some kind of 2-dimensional sketch by someone. It's 3D. It's a solid. If it's a road project, it's a solid. Are you okay? We need to know where's the road. Are you okay? In terms of, let me just say, on the horizontal plane. Okay, on the specific horizontal plane, where does the road, if we were to project the whole project onto a single plane, one specific horizontal plane, we'll have that plan position. Is that okay? All right. So it's important that we establish points with known eastings and northern coordinates. Is that okay? So, like I keep saying, then the northerns are your Y, your eastings are your X. That one is easy. Is that okay? Then we have latitudes and departures anyway. So latitudes are what, X, and then departures are Y. It's just semantics anyway. Sometimes it depends on which country whoever is writing. But it's very important to establish points on the site. So always picture this. Engineering surveying, picture yourself on the ground. You are supposed to, implement a design. Are you okay? So you should have had the design first. Then you are out there on a certain region, study areas, a place, a project area. Okay, which is what we are calling site. And you need to have eastings and northern coordinates. Okay. Now, quickly, we should distinguish between the eastings and northern coordinates from a local datum in which you've assumed some origin on the site. Okay, so you can actually have your own local coordinate system in which you don't have to, talk about, even then you can still talk about eastings and northerns if you can actually assume a north. So you can assume that, okay, for this project, my north is here, just so that you can put up the, maybe if it's a building project, then you can reference to it. Okay. So the coordinates, the eastings and northerns are very important. What you find on the ground, excuse me, is some sort of pillar or some benchmark or something, and then there's a mark on top of it, and then you are supposed to now make reference to it when you set up your theodolite somewhere. Okay, so either someone put something on top of it that you actually measure to. Okay, and so the control, the eastings and northerns are actually supposed to look at this way, that if you really assume that there was a line going through that point, okay, which was offset from the x-axis by a certain distance, that will be your eastings. Are you okay? And then the offset from the y-axis in the particular coordinate system, that will be your y. Are you okay? Okay, so offsets from y are x's, offsets from x's are your y's. Offsets from your x's, your x-axis will give you the change in this direction, the northern direction. That will become your northern. Are you okay? So please, it's important to know that we need that so that we can actually place our design in context. Okay, because let's not forget that you don't design on a blank sheet, you design on a plan. Are you okay? You don't design on an empty sheet. You have an existing base map based on which you are designing. Okay, so horizontal control points allow us to set out the design points. That's a basic thing. So if you don't have the horizontal control, you wouldn't even know where to have the thing, let alone where to. What I mean by the thing, I'm talking about the design, whatever you want to do. If it's a road, if it's a pipeline, are you okay? If it's a building, where should I put it? And sometimes where you want to put it is more important than even the work, getting the work done. At the end of the day, you need to, of course, set out, but where exactly should I have it done? There are a lot of considerations that should come in. There's a basic principle that should be followed when you are establishing your horizontal controls. You need to work from the whole to the part. I think you probably heard this before. Abraham, have you heard this before? Working from the whole to the part. He's gone. Okay, that's fine. So we work from the whole to the part. In surveying, generally, you work from whole to part. And it involves starting with a smaller number of very accurately measured control points. Okay, so you can call that the first level, which includes the area in question using etc. Let me just continue that. Obviously, before you actually establish a country and say Ghana, when we draw the Ghana map and everything, there's a certain first level of control points that are established. That is the whole idea. That's the principle, okay, behind doing going by the whole to part principle. Goes like this. Before you can draw, okay, the outline of Ghana like that, you should have started with some sparsely distributed control points. Are you okay? So for every country in the world, that's the first thing that is done. To establish the boundaries, you will need to have control points, okay, which are interconnected. Are you okay? So using trigonometry, and you're able to calculate the coordinates, all right? And these are only a few controls that form a network. So there's like a network of controls that allows you to, now establish other controls. Are you okay? All right. So it's a whole topic: geodetic control, network control. So yep, we need to have a first level of controls. So for a project, the same principle should be followed. You don't just go straight away. Are you okay? And then you want to just set out. You have to start from some primary controls. Are you okay? It's very important. Start with some primary controls. Okay, so you set out a second level of control point. So you can see that this is like primary controls to secondary control. And this one should get closer to the site. It's very important that you set out and you extend control. Are you okay? So the second level can then be used either to set out the design points of the scheme. Straight away, you can just stand on the secondary control and start setting out. You know, the scheme is like the design. If a scheme means design, it's okay. So a blueprint. You can also go ahead, establish a third level of control points as necessary. So it depends. You see, when people finish their engineering programs, one of the challenges that they have is that they're not able to apply common sense. Are you okay? It happens to a lot of, undergraduates who finish their program on the side. It's not rocket science. So you see the question, we are not being like very strict on whether we should set out from the second level of controls. We are saying or to establish a third level of control point as necessary. Is that okay? So you don't go say, I was told I should be doing this. No, use your head. That is from experience. That's what I can tell you. So the process is one of extending the control throughout the site until all design points are in. In other words, you want to extend the control to fit. You don't just extend the control. So from a surveyor's point of view, I know how to extend control. I know how to, what do I mean by extend control? It means you know one control point and you want to establish a new one from the existing. Is that okay? Usually it just takes you measuring to on the known point. Are you okay? And then that's it. You measure distance and angles to the known point, and then you work out, what the new coordinates should be. I think it's not difficult. Are you okay? You can always do that. Change in east and north. Once you have a bearing, you can do that. I mean, seriously speaking, let me go back to my whiteboard for a moment. So if you have a control point, this is your site. You're supposed to put up this, okay, this structure. You will need to have the control so close to the site. So you have a triangle. Okay, hold on, guys, just a second. Just a second, I'll be with you. All right. Okay, so continue from there. If you have a pillar that's been established close to the sites, you can imagine that there are other controls in the vicinity. Okay, so usually a triangle with a circle, within a circle can be used to represent a control point. Okay, so vertical control, horizontal control. Are you okay? All right, usually that's a symbol used. Okay. All right, you can then establish a new control by, of course, you can just cite this, and then if you don't know this control point here, then you can measure to it. So you measure an angle. If you know the bearing of this line, excuse me, it's a matter of adding the included angle here. All right, so the bearing of this line then, excuse me, will be, if you actually do the trigonometry, isn't it? There's a difference between this and that. Are you okay? All right. So then you have the bearing, and once you have a bearing and you have a distance, you can also determine, of course, you know the coordinates at this point, and you can just literally work out the coordinates. You can add it on, changing easting, changing northern. Okay, because the change doesn't have to reference the actual number. So the control may be a very large value. Control point may be 5, 4, 8, 200, 100, 1.1. Are you getting that? So this is a typical eastern and northern. Are you okay? Value that we can actually work differences in eastern, delta northern. Are you okay? And then use that to work out, a bearing, or use it to even extend the control. If I know the coordinates for this point, I just add on the change in eastern, change in northern. That is what extending control entails. Is that okay? So you are extending control. It involves all this. You need a field line. You need to set it up. So all the things you learn about how to use an ED, a total station, apply. Backsiding, included angles, etc. So inevitably, the accuracy of the control will decrease slightly as each new level is established. Okay, so let's just cut it there. So the accuracy is actually transferred. Let me just say that if a particular control was not well established and has a lot of error in it, then subsequent controls that are extended from that control will inherit those errors. So the accuracy of the control will decrease slightly as new level is established. Are you okay? So the level here is the first level of control, second level of control, third level of control. It's English language. You can look at it in terms of primary control, secondary control. Are you okay? So please, this is a lecture. Everything I'm saying is as equally important as a lecture note. So let's take note of that, because most of the time it's semantics. Are you okay? Semantics. All right. So working from whole to part, you see the diagram I'm making over there. This even a better one for you to even understand. So you have to set out this structure. Are you okay? Usually that's what engineers are doing. They're setting out, they're saying, break this building because according to my design, you see, you have to just set out. Are you okay? It's very important. Setting out everything we are talking about. You can be designing in the house, in the office. If it doesn't get set out, nothing gets done. Okay. Right. So the blue outline, okay, is your actual project. Okay. Now let's see all the other lines. So like I said, a triangle is a horizontal, it represents a horizontal control. Okay. Now let's look at the round symbol without the infill. Okay. So that's a circle without the fill. That is the main site control. So let's assume that you run a traverse. Okay. If you run a traverse, then in that case, we have the points which we're using the traverse, and you are picking and choosing your control, your second level of controls based on the site and the nature of the site. Maybe if per this design, it's okay to put these points, okay, but depending on the design you have, you may want to consider, okay, when I look at the project, if I put one control here, I'll be able to, to set out a certain part of it, which is more complicated. Okay, now the circle symbol with an infill, this is the secondary side control. Are you okay? So that one is being extended from the, are you okay, the main side control. Are you okay? So there's a first level, second level, third level per this diagram. Okay, so that's the national grade. You can see that triangle, and then the other ones, I think it's quite clear. Horizontal control points should be located as near as possible to the site. So that is the fundamental thing. In other words, before you actually set out, if you don't have, if there's a project to be done, okay, we need you to do this project near the shore, Temash, harbor, blah, blah, blah. That's fine. How much is in it? $100,000. Oh, that's beautiful. We'll get this down for you. Okay. Now, one of the critical things is to find out if there's a control. Yeah. So there's a survey and mapping division in Ghana, previously known as a survey department. They are in charge of these controls. Find out if there is any closer to that area, they can always tell you. And they tell you whether it's good or not. Okay. And then you can use that. So you put it in open positions for ease of working. Okay. So you shouldn't kind of put in a place where now it becomes difficult. Nobody is actually chasing you. So as part of your recce or reconnaissance, you need to check these things. Wow, this control, it won't be good here. So I want to find a better place to locate the control. So basically, the location of these controls is very important. They should be well away, up to like 100 meters if necessary, since it's easily accommodated by modern EDM. So this is not modern, this is modern. You can correct that statement. And so get it close, get the controls close to the site, but not too close. Why? Because there are earthworks going on. Are you okay? And as vehicles move, traffic, are you okay, builds on sites, because we don't forget that there's transportation of material to the site. So if you put your control in the way just because you think, well, I was taught how to do this and I've qualified as an engineer, I'm out there, you will now end up losing your controls. It's going to cost you to re-establish it. And trust me, it takes time to get certain things. And once you have to revisit an activity, you should know that it's creating an extra cost, which may not have been budgeted for. So horizontal controls have to also be marked with permanent, are you okay, material like concrete. Are you okay? Here you can see we have even a steel bolt that has been pushed into kind of, are you okay, into kind of some kind of concrete block. In other words, the concrete was mixed and then the steel bolt was actually placed in there. Are you okay? So that's a typical dimension. A concrete pillar with a plate embedded in the top to take a tubulite. So there are interesting ways that these are built. I've seen one in which you have it standing there like some kind of monument. You can see it's like some steel material that has been used and it's guarded, protected. You even wonder that what is this thing? It is a control, are you okay, that you need for your work. And there are ones that you shouldn't move. There are those that can be moved and shifted, but there are those that should be kept permanent. Okay, so here, there's a permanent control station for you. All points must be clearly marked with their reference numbers or letters. Is that okay? All points must be clearly marked, their reference numbers or letters. And they should be painted so that it can be easily found. So you see, normally you have your site plan. You need to mark where the controls are, because don't forget that the design, you don't work, if you're not careful, you can be working on the site, you just come back, before you're aware, you're exhausted. Are you all right? And that is not a way to work. So your design should have, there should be a correspondence between the design, the scheme, are you okay? And then the actual control. When it comes to horizontal control, you need to mark them on your plan, your side map. They should also be surrounded by brightly painted. You see, all this so that people know that it's there. Are you okay? To make them clearly visible to the side traffic. In other words, you can put some kind of flag on it. Are you okay? Maybe red flag. You can just guard it so that it's only when the instrument is set up, are you okay, that you can go in there. But then it shouldn't be like everybody can just, people don't mind just kicking it, even though they really care about the project. So this is very, very important. Horizontal control, we need it to, you know, to get our scheme set up. Okay, we need it to get our scheme set up. Without it, in fact, it will be a total waste of time. You're gonna struggle with it. Okay, so horizontal control surveys. Let's look more at horizontal control surveys. So I'm going to share the screen. And then maybe there's something that we missed, then we will look at it. If there's nothing we missed, we just move on. Okay, so here you can definitely say that here is some sort of primary first level control. Are you okay? All right. So I think we really touched on this one. Yeah, control points. The control survey is what yields the control points. Okay, like the traverse or whatever it is. Yeah. So first control points are usually built as control stations. I think we've talked about this. This is just repeating some of the things we've said, but it's okay. All right. So this is a primary triangulation that I talked about it. So you can see this in terms of the picture. This is for Netherlands, 77 points have been used. Okay. So your project could be somewhere. Let me get somewhere in the very small area. Are you okay? So you may want to go there, go to a point, and then extend it. Are you okay? To your project area. Okay. Or there may be other works that have been done that brought it closer. Okay. I think I'm over emphasizing this one. Okay. I want to see if there's something we messed up. You can also have benchmark points. Are you okay? They are not necessarily established at high places. So in Ghana, for example, a place like Legon, yeah, where we have University of Ghana, the Legon Hall or so. There's particular hall where the vandals are. I don't know if that's Legon Hall. Yeah, there's a control point there because that place can be seen. In fact, if you drive around Accra, you realize that that place is always visible. And there are so many places around like that we have to have very high, elevation that can be used. All right. Horizontal control may be established by, I think we talked about it, traversing, yeah. Triangulation, triangulation is what we're looking at the top. You can also have trilateration, so it's the way it's been done. Triangulation makes you more of the angles, and you can measure the angles. Trilateration considers measuring the distances, okay, and then see a few angles. GPS, we all know that GPS has come to stay. We are using it in our phones anyway. Photogrammetry, yes, photogrammetry is another source. I think we all need to appreciate these data acquisition methods, but yeah, at the end of the day, everything is about control. To be able to represent our world, to design it, etc. So traversing and triangulation, measuring angles of triangles, like I said. Okay, I think we can look at it more, but I don't. Basically, that will be it. I will give you material, extra materials if I feel it's not sufficient. All right. Total stations. So total stations are like those equipments that electronic allow us to measure distances electronically. Yeah, they are also called EDMs, electronic distance measurement equipment. They can be essential help for our trilateration. I mean, back in the day, they used chains to measure distances. Okay. So when it comes to control, it was like you had to be physically strong to be part of the team. It didn't have anything to do, even if your intelligence was as important as your strength. Yeah. Okay. So these are all traditional methods: traversing, triangulation. GPS seem to be the way we're going these days. Drone surveys, photogrammetry. You keep hearing on this by the time you finish your program. Okay. So trilateration stands on the system of triangles where only lengths are measured. So as I just said, the concentrated focus is on the length. All right. Of course, there are formulas that back the decision to measure only distances. So angles. So GPS, of course, they're expensive, but well, they'll pay off if you are going to be needing this for building a national geodetic network where the controls at the first level. Are you okay? So traverses, I'm sure you know of traverses. Ibrahim, do you know what a traverse is? Do you know, have you done some traversing before? Abraham, have you heard of traversing before? Do you know what it is?
No, please, sir.
Wow, have you done some surveying before this course? Have you done some basic surveying? Have you done any surveying course before this? You're in level 300, isn't it? Yeah. Okay, let's move on. So in traversing, so we measure distances and angles between the points. Okay. And then these points are now becoming controls. So, okay, so these points can serve as control stations. All right. And then you can now move from the traverse, but you see the traverse is adjusted. Are you okay? Why do we talk about adjusting it? Because you see, these are human beings measuring distances, looking through these instruments, and then turning the telescope. And when you finish with a traverse, you realize that there's what we call a misclosure or an error. All right. So you have to then adjust it so you have an acceptable disclosure. Okay. So traversing is used usually for smaller areas or on areas with many obstacles. All right. Methods are appropriate for land and property surveys as well. Now you can have an open or a closed traverse. So in other words, if you go all the way around and you come back to where you started from, then you have a closed traverse. Is that okay? So in other words, you can have a traverse in which you move like that, you move like that, you move like that, you move like that. So all these points are like pillars on the ground. Okay. All these points are pillars. All right. It's possible that you only know one coordinate when you start this one. You may just know the coordinate of one of the points. Is okay. But what you do is that you measure what we call included angles between these. And then as you do that, you can then work out the bearings. Okay. And then by extension, you can work out the coordinates at the other end. I think the focus on this course is not to talk about traversing, because I am assuming that you've been taught traversing elsewhere. If you've not, then obviously we're going to spend a lot of time talking about that, this one. Yeah. So traversing works like that. And then of course, if you sum the angles within the polygon, you're supposed to get a certain value. And if you don't get that, then you can find a difference and then work out. Are you okay? Either you distribute the errors or find out where if you have a gross error. So we have, errors which are kind of normal. Are you okay? And then we have errors that are gross, not normal. Right. So instead of you having that closed traverse, you can actually have an open traverse. In other words, let's assume you need to go do something in the countryside. Okay, there's a control on the main Accra Kumasi road. Okay, and so this is the Accra Kumasi road, and then there's one control, horizontal control, that you want to actually use. Okay, meanwhile, your village branches off here. Just trying to explain to you one of the reasons why you can have. It's not even about your village. It's really about the construction of a road, if you like, in that area. You need some controls or some dam down there. One constituency, one dam, right? I'm not doing politics here. So, but then if I'm to extend this, then you can see that I want to establish a control here. All right. So how do I carry on? Okay. So I keep on planting more pillars as I go. All right. Then there's another one there. Okay. So to close this may not be possible. Are you okay? You just keep going. So in that case, you have an open traverse. It's not easy to find out that you don't have a polygon. Are you okay? To check the total sum of angles and in order. So the only way you may want to look at closing up like this is to find another known coordinate and then to close on it. So that will be an open traverse for you. That's the nature of it, what an open traverse is. Okay, so there you go. In pictures, so more pictures for you. A picture is over 1,000 words. So that's a closed traverse. Okay, this one is a closed traverse. And then we have on the left hand side, we have an open traverse. This one is an open traverse. So you can see that here, we're not coming back to where we started from. Okay. Now check the angles are being measured clockwise. Yeah. Clockwise. The included angles. Are you okay? Measured in a clockwise direction. The clock goes this way, doesn't it? All right. So open traverse, closed traverse. All right. There you go. All right. So for long traverses, checks on measured horizontal angles can be obtained by making periodic, of course. That is a bit gross. You could do that, but yeah, astronomical observations are able to yield the longitude. You can actually get the azimuth, okay, which is like the bearing, by observing the stars. But I think not for you. All right, we are not foreseeing that happening. Going to that instance. Control traverse station. The control stations which are used to fix control points must mark the point's position clear. Of course, I think we've said it. We overemphasizing on this one. Yeah. Okay. So let's move on from there. Go back to the PowerPoint. Okay. All right. So, well, Baselines. What are baselines? So usually when you are doing a survey, okay, you may want a certain reference point. The actual project is there. Are you okay? The actual project is there. We are not saying that transfer. There's something called there's something called precision, and there's something called accuracy. They are two different things. So the accuracy of a control point, a third level control point, may be so bad. Okay, but the work being done by the foreman and the people working on the site, the surveyor on the site, okay, may be very accurate, may be very precise. You understand? It doesn't mean your building is going to fall down. So the accuracy should be, distinguished from the precision of the work. So I can decide to even not use national coordinates to set out a building, but there can be challenges as well. All right, if you do that. Okay, so I'll go to win and price at this juncture. Okay, did I miss something on there? Okay. This is in the way. So obviously here, you can see that this is the very basic, excuse me, traditional way of setting out, if what we call detailing is okay. So as you can see, excuse me. All right, yes, so this bit is missing in what I was showing you. All right, so you can actually do, excuse me, some kind of error estimation, like I said. Okay. All right. So you can also, this is a typical traverse. Here, the word courses is being used, like the azimuth of the courses, like bearing of a line. Are you okay? All right. So you can see here we are measuring angles. So please know how to put in these values on your calculator. I keep saying it's very important. All right. Okay. So there you go. That's one fact that we should all take note of. The sum of interior angles in any loop, closed traverse. So instead of saying closed traverse, we can say loop traverse. It's English language. Okay. So closed traverse. Yeah, show the typical example here. Loop traverse. Are you okay? All right. So n minus 2 times 180 will give you the total sum of angles in a loop traverse. Are you okay? Okay, so 90 times 4 is what? 360, right? So if I have 4 sides, that's a typical, example of how to prove it. Some formulas. If you have a square, then the sides are 4 minus 2 times 180. So that's 2 times 180, that's 360. Okay. And naturally, a square is actually 90 at the corners. So 90 times 4 then gives you 360. So these formulas have to be tested. Okay, get to the bottom of it. So there's a table here with the angles and adjusted, and we're able to adjust because we sum the angles and we're not getting the total sum. Okay, I only use this for 4 sides. So if I have 5 sides, then things will change. The formula will now change. Okay, that will be 3 instead of 2, the difference here. All right. So the adjustment is as a result of the difference if you look at the total number of points here in the table, I don't know if you've learned these things and you're pretending you haven't, but honestly speaking, this is something I'm sure you've done. But you can let me know if you're not, because most of the time you've been taught something, but you still pretend you don't. Are you okay? So that is basically it. 540. Why are we having 540? Because the sides are, how many sides we have? This 1, 2, 3, 4. Yeah. 3 times 180. 300 plus what? 300 plus what? 240, isn't it? That'll give me 540. Yeah. Okay. So we now have to correct these. So as you can see, for every angle, we are correcting by 30 minutes. Is okay. It's 30 seconds, sorry. 30 seconds. So 64, 53, 30. And don't forget that in these values here, the seconds, the maximum number is 60. Are you okay? So 35, 15. If we reduce it, are you okay? By 30, take the 30 off, you get 15. Okay, I understand. All right. So of course, at the end of the day, you need to make sure that these errors is just gone. Like all of them are gone. All right. So if you sum them, then you should now have your 540 after the correction. That is how traverses work. In fact, it's one of the basic things that everyone must actually learn. Are you okay? All right. So we have what we call a compass rule. I mean, in fact, coming in for this lecture, I assumed that you had done this before. Are you okay? But I don't know if it is. I'll have to find out, because if you haven't, then we'll have to give you. I don't know. I doubt if engineering surveying traversing is for another course that you did before this class, please. So I'm assuming you know all this. Triangulation is based on measuring angles using theodolites and a network of triangles. I think we talked about that. Okay. And then you convert these to coordinates, okay, by making use of some base distance, and then you just keep going. Is that okay? Maybe this trigonometry. So the formulas are available for us. Okay. So yeah, you have to use your head when it comes to these things. What is this? Yeah, that's supposed to be some kind of steel chain that was used. Okay, so let's look at this one. 100 feet Ramsey chain used in survey to measure distances. We don't do this anymore. It's okay. But students always have to be told so that they know. All right, so you have to add some correction due to expansion. Oh my God. All right, so the beginning, strangulation employed chains, of course, we talk about that. I think in surveying, land surveying, you learn about that. Trilateration, simplified method. I think we already talked about that. Least square method for data reduction. So let's not forget that the correction we're doing then is to just find the error, distribute it, but then ideally the method to be used for adjusting the data you have is called least squares adjustment. I don't think we can do all that in this one. But statistically, yes, that is what it looks like. Find the error, the square of the residuals. If I add all this to it, you will not be able to understand anything in this course. So I think we just skip that for now. Just move on. Let's go back to the PowerPoint. So this is going to end, Zoom session will end in 9 minutes. And then we go back to the same link. When it closes, I want you to just click the same link. Okay. Okay, so unit and price. I think we are missing something on baselines and reference gates. So let's go to quickly before we come back to this. Okay, so I want to share my PDF. Okay. not baselines. Okay, I want to touch quickly on baselines and just go. Okay, so we talked about baselines. It's a reference line. I think I touched on that. This is a baseline may be specified by the designer. Okay, whoever is designing baselines can take many forms. They can be run between existing buildings. Okay, right. From which, but really these are all traditional methods. Okay, but you never know. It may help you. You know, GPS may not be available all the time. The accuracy is decreased if two baselines at right angles to each other. So you normally don't use just one base, like have two baselines. The idea is that you make reference to that line, like anytime. All right. Okay, so yep, let's move on. I want to touch quickly on reference grids. So control grid enables points to be set up over a large area. Okay, so the grid we can look at in terms of working on the construction site, and then so in fact here we've actually differentiated between survey grade, site grade, structural grade, but the idea is that you want to find a way of locating, you know, setting out columns and stuff like that, because most projects are like evenly spaced. You understand what I'm saying? Most projects are evenly spaced. So nobody does a design. Architects don't design, and then everything seems to not to be equal. Like when you look at every building, structure, you always have this kind of equal interval. So the grid allows you, they are all equally spaced lines, okay, that you superimpose on your project so that you can quickly, you know, work. Sometimes the values are actually associated with the grid. So if on a particular project I work, that's how it was done. Okay. The grids had coordinates. Okay. So whether they are local or they are coming from a national, you could. You can just draw any grid and then find out what the values are. You know, but they have to be in such a way that you can easily, you know, work with them. Need very whole numbers as well. So site grade, survey grade. So the survey grade is drawn on the survey plan. Are you okay? From the original Travis or triangulation scheme. You can have the site grade, as by design. It's usually related to in some way to the survey grade. Are you okay? And should, if possible, actually be the survey grade. Okay. All right. The advantage of this being that if the original control stations have been permanently marked, then the design points will be on the same coordinate system, and setting out is really. Okay, so the whole idea is that I should be able to set out without much effort. Okay, so we can have the structural grade, you can have a secondary grade. It's all up to you. Some projects may not even need it. Okay. All right. So secondary grade is established inside a structure from the structural grade when it is no longer possible to use the structural grade to establish internal features. So let's not forget that when you go into a huge project, okay, a very large project, complex projects, let me say, you may want to know some parts of the whole project need to be set out. And you can't just set them out from the way you feel. Are you okay? Okay, now we finish the building. So hey, put some, you know, column here. Just do whatever you like. You just can't do whatever you like. You have to go still according to the design, and the design has the coordinates associated with it. Are you okay? So we may also make use of pegs. If I sometimes use this spray, people use this spray for graffiti. It can be used also for marking points of interest. Okay. All right. So we go to methods of vertical control. Okay. So let's understand that vertical is just one dimension. You measure a height in one dimension like that. But when we talk about horizontal control, you need the two pairs of numbers for you to be able to fix something. When it comes to horizontal control, you need to look at the eastern and the northern. When it comes to vertical control, it's just the height at some point. But without the horizontal control and establishing in plan what your design is, you can't even talk about the vertical. Okay, so please, since your questions we tend to ask you analytical, very, let me just say difficult questions, you need to understand what I'm saying right now. That someone can give you the height at a certain point, but without the easterns and northerns, there's no way you're gonna be able to work with that height. Are you okay? Because you wouldn't even know where it is in the first place. So on paper, you have some heights, but you need to go with the easterns and northerns. So normally you have vertical controls. They always have some kind of easterns and northerns associated with them. Okay, interesting. So in order that the design points on the works can be positioned at their correct levels, vertical control points of known elevation relative to some specified datum must be established on the site. It's very, very important. Are you okay? How high is something is very, very important. If I want to come where I live, where I live, you realize that the way it was built, the house is a very simple building. Are you okay? 2-bedroom house. It's a particular wall that you see that dust settles on the side of the wall. Dust shouldn't settle on a wall. You understand what I'm saying? If we still go by Newton's law, are you okay? Of gravity, dust is supposed to just go along the wall because the wall is supposed to be truly vertical, the line along which an apple will always fall. Are you with me? But we are having a wall here in this house which has some dust settling on. You can see dust. It only tells you that the wall isn't truly vertical. But obviously in planimetry, you should be able to see a wall like just one. If it's tilted, then you start having something else. I mean, I'm talking plenty. Okay, so this next session that we are dealing with, in fact, this session is going to end in 1 minute. Please click the same link again and rejoin me. We're going to talk about vertical control. Is that okay? So let me see you then.